Business intelligence.
Business intelligence is a set of theories, methodologies, architectures, and technologies that transform raw data into meaningful and useful information for business purposes. BI can handle enormous amounts of unstructured data to help identify, develop and otherwise create new opportunities. BI, in simple words, makes interpreting voluminous data friendly. Making use of new opportunities and implementing an effective strategy can provide a competitive market advantage and long-term stability. Generally, business intelligence is made up of an increasing number of components. These are multidimensional aggregation and allocation, denormalization, tagging and standardization, real-time reporting with analytical alert, interface with unstructured data source, group consolidation, budgeting and rolling forecast, statistical inference and probabilistic simulation, key performance indicators optimization, version control and process management, open item management. BI technologies provide historical, current and predictive views of business operations. Common functions of business intelligence technologies are reporting, online analytical processing, analytics, data mining, process mining, complex event processing, business performance management, benchmarking, text mining, predictive analytics and prescriptive analytics. Though the term business intelligence is sometimes a synonym for competitive intelligence, because they both support decision-making, BI uses technologies, processes, and applications to analyze mostly internal, structured data and business processes while competitive intelligence gathers, analyzes and disseminates information with a topical focus on company competitors. If understood broadly, business intelligence can include the subset of competitive intelligence.
History.
The term business intelligence was originally first phrased by Richard Miller Devens in the Cyclopedia of Commercial and Business Anecdotes from 1865. Devens used the term to describe how the banker Sir Henry Furness gained profit by receiving and acting upon information about his environment, prior to his competitors. Throughout Holland, Flanders, France, and Germany, he maintained a complete and perfect train of business intelligence. The news of the many battles fought was thus received first by him, and the fall of Namur added to his profits, owing to his early receipt of the news. Devens, 1865, pages 210. The ability to collect and react accordingly based on the information retrieved, an ability that Furness excelled in, is today still at the very heart of BI. In a 1958 article, IBM researcher Hans-Peter Lund used the term business intelligence. He employed the Webster's Dictionary definition of intelligence, the ability to apprehend the interrelationships of presented facts in such a way as to guide action towards a desired goal. Business intelligence as it is understood today is said to have evolved from the decision support systems, DSS, that began in the 1960s and developed throughout the mid-1980s. DSS originated in the computer-aided models created to assist with decision-making and planning. From DSS, data warehouses, executive information systems, OLAP and business intelligence came into focus beginning in the late 80s. In 1988, an Italian-Dutch-French-English consortium organized an international meeting on the multi-way data analysis in Rome. The ultimate goal is to reduce the multiple dimensions down to one or two, by detecting the patterns within the data, that can then be presented to human decision-makers. In 1989, Howard Dressner, later a Gartner Group analyst, proposed business intelligence as an umbrella term to describe concepts and methods to improve business decision-making by using fact-based support systems. It was not until the late 1990s that this usage was widespread.
Business intelligence and data warehousing.
Often BI applications use data gathered from a data warehouse or a data mart. A data warehouse is a copy of analytical data that facilitates decision support. However, not all data warehouses are used for business intelligence, nor do all business intelligence applications require a data warehouse. To distinguish between the concepts of business intelligence and data warehouses, Forrester Research often defines business intelligence in one of two ways. Using a broad definition, business intelligence is a set of methodologies, processes, architectures, and technologies that transform raw data into meaningful and useful information used to enable more effective strategic, tactical, and operational insights and decision-making. When using this definition, business intelligence also includes technologies such as data integration, data quality, data warehousing, master data management, text and content analytics, and many others that the market sometimes lumps into the information management segment. Therefore, Forrester refers to data preparation and data usage as two separate, but closely linked segments of the business intelligence architectural stack. Forrester defines the latter, narrower business intelligence market as referring to just the top layers of the BI architectural stack such as reporting, analytics and dashboards.
Business intelligence and business analytics.
Thomas Davenport argues that business intelligence should be divided into querying, reporting, OLAP, an alerts tool, and business analytics. In this definition, business analytics is the subset of BI based on statistics, prediction, and optimization.
Applications in an enterprise.
Business intelligence can be applied to the following business purposes, in order to drive business value. Measurement, program that creates a hierarchy of performance metrics, see also metrics reference model, and benchmarking that informs business leaders about progress towards business goals. Business process management, analytics, program that builds quantitative processes for a business to arrive at optimal decisions and to perform business knowledge discovery. Frequently involves data mining, process mining, statistical analysis, predictive analytics, predictive modeling, business process modeling, complex event processing and prescriptive analytics, reporting enterprise reporting, program that builds infrastructure for strategic reporting to serve the strategic management of a business, not operational reporting. Frequently involves data visualization, executive information system and OLAP, collaboration platform, program that gets different areas, both inside and outside the business, to work together through data sharing and electronic data interchange, knowledge management, program to make the company data-driven through strategies and practices to identify, create, represent, distribute, and enable adoption of insights and experiences that are true business knowledge. Knowledge management leads to learning management and regulatory compliance. In addition to the above, business intelligence can provide a proactive approach, such as alert functionality that immediately notifies the end user if certain conditions are met. For example, if some business metric exceeds a predefined threshold, the metric will be highlighted in standard reports, and the business analyst may be alerted via email or another monitoring service. This end-to-end process requires data governance, which should be handled by the expert.
Prioritization of business intelligence projects.
It is often difficult to provide a positive business case for business intelligence initiatives, and often the projects must be prioritized through strategic initiatives. Here are some hints and advantages to increase the benefits for a BI project. As described by Kimball, you must determine the tangible benefits such as eliminated cost of producing legacy reports, enforce access to data for the entire organization. In this way, even a small benefit, such as a few minutes saved, makes a difference when multiplied by the number of employees in the entire organization. As described by Ross, Weil and Robertson for enterprise architecture, consider letting the BI project be driven by other business initiatives with excellent business cases. To support this approach, the organization must have enterprise architects who can identify suitable business projects, use a structured and quantitative methodology to create defensible prioritization in line with the actual needs of the organization, such as a weighted decision matrix.
Success factors of implementation.
Before implementing a BI solution, it is worth taking different factors into consideration before proceeding. According to Kimball et al., these are the 3 critical areas that you need to assess within your organization before getting ready to do a BI project. The level of commitment and sponsorship of the project from senior management, the level of business need for creating a BI implementation, the amount and quality of business data available.
Business sponsorship.
The commitment and sponsorship of senior management is, according to Kimball et al., the most important criteria for assessment. This is because having strong management backing helps overcome shortcomings elsewhere in the project. However, as Kimball et al. State, even the most elegantly designed DWBI system cannot overcome a lack of business sponsorship. It is important that personnel who participate in the project have a vision and an idea of the benefits and drawbacks of implementing a BI system. The best business sponsor should have organizational clout and should be well connected within the organization. It is ideal that the business sponsor is demanding but also able to be realistic and supportive if the implementation runs into delays or drawbacks. The management sponsor also needs to be able to assume accountability and to take responsibility for failures and setbacks on the project. Support from multiple members of the management ensures the project does not fail if one person leaves the steering group. However, having many managers work together on the project can also mean that there are several different interests that attempt to pull the project in different directions, such as if different departments want to put more emphasis on their usage. This issue can be countered by an early and specific analysis of the business areas that benefit the most from the implementation. All stakeholders in project should participate in this analysis in order for them to feel ownership of the project and to find common ground. Another management problem that should be encountered before start of implementation is if the business sponsor is overly aggressive. If the management individual gets carried away by the possibilities of using BI and starts wanting the DW or BI implementation to include several different sets of data that were not included in the original planning phase. However, since extra implementations of extra data may add many months to the original plan, it's wise to make sure the person from management is aware of their actions.
Business needs.
Because of the close relationship with senior management, another critical thing that must be assessed before the project begins is whether or not there is a business need and whether there is a clear business benefit by doing the implementation. The needs and benefits of the implementation are sometimes driven by competition and the need to gain an advantage in the market. Another reason for a business-driven approach to implementation of BI is the acquisition of other organizations that enlarge the original organization. It can sometimes be beneficial to implement DW or BI in order to create more oversight. Companies that implement BI are often large, multinational organizations with diverse subsidiaries. A well-designed BI solution provides a consolidated view of key business data not available anywhere else in the organization, giving management visibility and control over measures that otherwise would not exist.
Amount and quality of available data.
Without proper data, or with too little quality data, any BI implementation fails. It does not matter how good the management sponsorship or business-driven motivation is. Before implementation, it is a good idea to do data profiling. This analysis identifies the content, consistency and structure of the data. This should be done as early as possible in the process, and if the analysis shows that data is lacking, put the project on the shelf temporarily while the IT department figures out how to properly collect data. When planning for business data and business intelligence requirements, it is always advisable to consider specific scenarios that apply to a particular organization, and then select the business intelligence features best suited for the scenario. Often, scenarios revolve around distinct business processes, each built on one or more data sources. These sources are used by features that present that data as information to knowledge workers, who subsequently act on that information. The business needs of the organization for each business process adopted correspond to the essential steps of business intelligence. These essential steps of business intelligence include but are not limited to: go through business data sources in order to collect needed data, convert business data to information and present appropriately, query and analyze data, act on the collected data. The quality aspect in business intelligence should cover all the process from the source data to the final reporting. At each step, the quality gates are different. Source data. Data standardization, make data comparable, same unit, same pattern. Master data management, unique referential. Data standardization, make data comparable, same unit, same pattern. Master data management, unique referential. Operational data store, ODS. Data cleansing, detect and correct inaccurate data. Data profiling, check inappropriate value, null empty. Data cleansing, detect and correct inaccurate data. Data profiling, check inappropriate value, null empty. Data warehouse. Completeness, check that all expected data are loaded. Referential integrity, unique and existing referential over all sources. Consistency between sources, check consolidated data versus sources. Completeness, check that all expected data are loaded. Referential integrity, unique and existing referential over all sources. Consistency between sources, check consolidated data versus sources. Reporting. Uniqueness of indicators, only one shared dictionary of indicators. Formula accuracy, local reporting formulas should be avoided or checked. Uniqueness of indicators, only one shared dictionary of indicators. Formula accuracy, local reporting formulas should be avoided or checked.
User aspect.
Some considerations must be made in order to successfully integrate the usage of business intelligence systems in a company. Ultimately, the BI system must be accepted and utilized by users in order for it to add value to the organization. If the usability of the system is poor, the users may become frustrated and spend a considerable amount of time figuring out how to use the system or may not be able to really use the system. If the system does not add value to the user's mission, they simply don't use it. To increase user acceptance of a BI system, it can be advisable to consult business users at an early stage of the DWBI life cycle, for example at the requirements gathering phase. This can provide an insight into the business process and what the users need from the BI system. There are several methods for gathering this information, such as questionnaires and interview sessions. When gathering the requirements from the business users, the local IT department should also be consulted in order to determine to which degree it is possible to fulfill the business's needs based on the available data. Taking on a user-centered approach throughout the design and development stage may further increase the chance of rapid user adoption of the BI system. Besides focusing on the user experience offered by the BI applications, it may also possibly motivate the users to utilize the system by adding an element of competition. Kimball suggests implementing a function on the Business Intelligence Portal website where reports on system usage can be found. By doing so, managers can see how well their departments are doing and compare themselves to others, and this may spur them to encourage their staff to utilize the BI system even more. In a 2007 article, H.J. Watson gives an example of how the competitive element can act as an incentive. Watson describes how a large call center implemented performance dashboards for all call agents, with monthly incentive bonuses tied to performance metrics. Also, agents could compare their performance to other team members. The implementation of this type of performance measurement and competition significantly improved agent performance. BI chances of success can be improved by involving senior management to help make BI a part of the organizational culture, and by providing the users with necessary tools, training, and support. Training encourages more people to use the BI application. Providing user support is necessary to maintain the BI system and resolve user problems. User support can be incorporated in many ways, for example by creating a website. The website should contain great content and tools for finding the necessary information. Furthermore, help desk support can be used. The help desk can be manned by power users or the DWBI project team.
BI portals.
A business intelligence portal, BI portal, is the primary access interface for data warehouse, DW, and business intelligence, BI, applications. The BI portal is the user's first impression of the DWBI system. It is typically a browser application, from which the user has access to all the individual services of the DWBI system, reports and other analytical functionality. The BI portal must be implemented in such a way that it is easy for the users of the DWBI application to call on the functionality of the application. The BI portal's main functionality is to provide a navigation system of the DWBI application. This means that the portal has to be implemented in a way that the user has access to all the functions of the DWBI application. The most common way to design the portal is to custom fit it to the business processes of the organization for which the DWBI application is designed. In that way the portal can best fit the needs and requirements of its users. The BI portal needs to be easy to use and understand, and if possible have a look and feel similar to other applications or web content of the organization the DWBI application is designed for. Consistency. The following is a list of desirable features for web portals in general and BI portals in particular.
Marketplace.
There are a number of business intelligence vendors, often categorized into the remaining independent pure-play vendors and consolidated mega-vendors that have entered the market through a recent trend of acquisitions in the BI industry. Some companies adopting BI software decide to pick and choose from different product offerings, best of breed, rather than purchase one comprehensive integrated solution, full service.
Industry-specific.
Specific considerations for business intelligence systems have to be taken in some sectors such as governmental banking regulations. The information collected by banking institutions and analyzed with BI software must be protected from some groups or individuals, while being fully available to other groups or individuals. Therefore BI solutions must be sensitive to those needs and be flexible enough to adapt to new regulations and changes to existing law.
Semi-structured or unstructured data.
Businesses create a huge amount of valuable information in the form of emails, memos, notes from call centers, news, user groups, chats, reports, web pages, presentations, image files, video files, and marketing material and news. According to Merrill Lynch, more than 85% of all business information exists in these forms. These information types are called either semi-structured or unstructured data. However, organizations often only use these documents once. The management of semi-structured data is recognized as a major unsolved problem in the information technology industry. According to projections from Gartner, 2003, white-collar workers spend anywhere from 30 to 40% of their time searching, finding and assessing unstructured data. BI uses both structured and unstructured data, but the former is easy to search, and the latter contains a large quantity of the information needed for analysis and decision-making. Because of the difficulty of properly searching, finding and assessing unstructured or semi-structured data, organizations may not draw upon these vast reservoirs of information, which could influence a particular decision, task or project. This can ultimately lead to poorly informed decision-making. Therefore, when designing a business intelligence DW solution, the specific problems associated with semi-structured and unstructured data must be accommodated for as well as those for the structured data.
Unstructured data versus semi-structured data.
Unstructured and semi-structured data have different meanings depending on their context. In the context of relational database systems, unstructured data cannot be stored in predictably ordered columns and rows. One type of unstructured data is typically stored in a blob, binary large object, a catch-all data type available in most relational database management systems. Unstructured data may also refer to irregularly or randomly repeated column patterns that vary from row to row within each file or document. Many of these data types, however, like emails, word processing text files, PPTs, image files, and video files conform to a standard that offers the possibility of metadata. Metadata can include information such as author and time of creation, and this can be stored in a relational database. Therefore it may be more accurate to talk about this as semi-structured documents or data, but no specific consensus seems to have been reached. Unstructured data can also simply be the knowledge that business users have about future business trends. Business forecasting naturally aligns with the BI system because business users think of their business in aggregate terms. Capturing the business knowledge that may only exist in the minds of business users provides some of the most important data points for a complete BI solution.
Problems with semi-structured or unstructured data.
There are several challenges to developing BI with semi-structured data. According to Inman and Nisevic, some of those are: physically accessing unstructured textual data. Unstructured data is stored in a huge variety of formats. Terminology. Among researchers and analysts, there is a need to develop a standardized terminology. Volume of data. As stated earlier, up to 85% of all data exists as semi-structured data. Couple it with the need for word-to-word and semantic analysis. Searchability of unstructured textual data. A simple search on some data, for example Apple, results in links where there is a reference to that precise search term. Inman and Nisevic, 2008, gives an example: a search is made on the term felony. In a simple search, the term felony is used, and everywhere there is a reference to felony, a hit to an unstructured document is made. But a simple search is crude. It does not find references to crime, arson, murder, embezzlement, vehicular homicide, and such, even though these crimes are types of felonies.
The use of metadata.
To solve problems with searchability and assessment of data, it is necessary to know something about the content. This can be done by adding context through the use of metadata. Many systems already capture some metadata, for example file name, author, size, etc., but more useful would be metadata about the actual content, for example summaries, topics, people or companies mentioned. Two technologies designed for generating metadata about content are automatic categorization and information extraction.
Future.
A 2009 Gartner paper predicted these developments in the business intelligence market. Because of lack of information, processes, and tools, through 2012, more than 35% of the top 5,000 global companies regularly fail to make insightful decisions about significant changes in their business and markets. By 2012, business units will control at least 40% of the total budget for business intelligence. By 2012, one-third of analytic applications applied to business processes will be delivered through coarse-grained application as-ups. A 2009 Information Management Special Report predicted the top BI trends: green computing, social networking services, data visualization, mobile BI, predictive analytics, composite applications, cloud computing and multi-touch. Other business intelligence trends include the following. Third-party SOA BI products increasingly address ETL issues of volume and throughput. Companies embrace in-memory processing, 64-bit processing, and pre-packaged analytic BI applications. Operational applications have callable BI components, with improvements in response time, scaling, and concurrency. Near or real-time BI analytics is a baseline expectation. Open-source BI software replaces vendor offerings. Other lines of research include the combined study of business intelligence and uncertain data. In this context, the data used is not assumed to be precise, accurate and complete. Instead, data is considered uncertain and therefore this uncertainty is propagated to the results produced by BI. According to a study by the Aberdeen Group, there has been increasing interest in software as a service, SaaS, business intelligence over the past years, with twice as many organizations using this deployment approach as 1 year ago, 15% in 2009 compared to 7% in 2008. An article by InfoWorld's Chris Kanarakis points out similar growth data from research firm IDC, which predicts the SaaS BI market will grow 22% each year through 2013 thanks to increased product sophistication, strained IT budgets, and other factors.